Good morning, HOD Professor E.K. Chaturvedi sir, my seminar guide, Vijay Tripathi sir, faculty members, and my final year batchmates. Myself, Gagan Pareek, currently pursuing my bachelor's degree in aeronautical engineering from University Department, Rajasthan Technical University, Kota. Today, I am pleased to be here in front of you all delivering my seminar presentation on lunar colonization. These are the topics that we'll be covering in today's presentation. The concept of lunar colony is intriguing. The existence of such a colony would enable man to conduct studies which he presently does not have the capability to make. For example, a lunar colony would offer man the chance to determine what degree of independence from Earth he may achieve. Man would be able to determine his capability to exist for a longer period of time in a hostile environment, while having to provide his own food and life support needs from local resources. The moon presently offers the unique opportunity to conduct such a study. The landing of US astronauts was seen as a precedence for the superiority of the free market socio-economic model of the US, and in this case, as the successful model for spaceflight, exploration, and ultimately human presence in form of colonization. If we talk about the lunar environment, we all know that it is very different from our Earth. And to make it habitable, we'll have to study the environment so that we can make necessary advancements. The atmosphere of the moon is rarefied with an estimate density of less than 10 is to power minus 13 times the Earth's atmosphere. Minimum density is 5.5 into 10 is to power minus 13 particles centimeter cube at very small solar flux. Knowledge on the geomagnetic properties help in the study of evolutionary history of the moon and the solar system. The magnetic field is useful in the determination of the electromagnetic properties of the Earth's interior as well as moons, solar winds and ionosphere environments. The magnetic field of the moon is weak and is less than 108 times of the Earth's field, which means the metallic core in the moon is small and probably less than 2% of its total mass. The thermal radiation from the lunar surface varies from 565 watts per meter at 200 km to about 5 watts per meter square at 2000 km. Albedo radiations varies from 151 watts per meter square at 200 km to 1 watt per meter at 2000 km. Galileo classified the moon's surface into two broad regions, Maria, comprising the dark areas, and the Terra, uplands or highlands, comprising the light areas. The most prominent feature of the moon, especially in the uplands, are the craters, ranging in size from small to as big as 227 kilometers in diameter and 5 kilometers in depth. There are also mountains on the moon with peaks as high as 3 to 6 kilometers. The selection of a colony site is very crucial. At the site will protect the colony from meteoroids and many other possible threats which might lead to the extinction of the colony. If we talk about the average temperature on the moon, the average temperature on moon varies from 100 degrees Celsius to minus 173 degrees, varies from day to night. The lunar diurnal cycle is more than 270 degree Kelvin peak to peak at the equator. Heated rocks are a slight advantage for the oxygen process. However, cooling of surface structures using a combination of high albedo, high emissivity coatings and refrigerations may be necessary. Sunlight is also very important while considering colonization, and on moon, the days and nights are about 354 hours each, with only small seasonal variations. Sunlight is everywhere except near the poles. The illumination at night will also be there because of the Earth. The full Earth as viewed from the moon is 50 to 60 times brighter than the moon seen from the Earth. The astronomical brightness magnitude of the Earth as seen from the moon is minus 17.3 compared to minus 28.8 for the Sun. If we talk about the eclipses, they happen twice a year. The duration of the eclipses are approximately 1 hour in the umbra region, followed by about 1.5 hours in the penumbra region. If we talk about the minerals, ilmenite is very crucial for water generation by reducing with hydrogen. However, many more rare elements are also present on the moon surface. A possible site which might be selected as the data from NASA is Kof crater. Now, if we consider the growth of a colony from an initial lunar surface base, which will consist of a small group of people, the principal program options involved considering the operation of lunar surface base with or without an operational orbiting lunar system. With present transportation systems, the initial growth of any lunar colony will be limited primarily by the weight of materials that can be delivered from Earth to the lunar surface. As a colony grows, it develops the ability to utilize lunar resources. The dependence on the weight of the material sent from Earth can be drastically reduced. The growth of a colony will be very fruitful as it will allow us to actually produce oxygen, food and power with the help of resources present on the moon itself. If we talk about a possible colony, the possible configuration of the colony is shown here. The integrated flowchart of all required subsystems for lunar colonization is also shown. Only the inputs to the system and subsystem interactions are depicted. It is recognized that not all provisions of colonization can be derived from known lunar resources. The central portion of the figure represents the central colony complex, which encompasses the living quarters, maintenance functions, laboratories, dining, recreation and storage and special use areas. Many subsystems will be used for different works while designing a lunar colony, like oxygen supply, power supply, life support systems, mining and excavations, etc. In any manned extraterrestrial activity, oxygen is a critical consumable. Establishment of a lunar colony presents a first opportunity to produce this commodity in space. Preliminary design studies have shown that if electric power and solar energy are available, plentiful supply of oxygen can be obtained from lunar finds. Life support systems for space applications have in general relied upon a storage system for certain life support needs. This system has been successfully applied for missions of short duration. However, it needs to be more developed for a longer duration missions. Mining and excavation will also be done as using the moon resources is very necessary, and for extracting those minerals, mining activities will be necessary. The power production methods will be either electrical or thermal. However, solar energy will be the most efficient as sunlight is present everywhere except the poles on the lunar surface. To conclude, the concept of lunar colony is very feasible. However, much research and development work is necessary before the colony is a reality. The lunar finds are known to be sufficiently small so that no initial size reduction is necessary before most material and manufacturing use. The sequence of growth of the colony started with the redefined lunar surface base and detailed the development of the colony. The rate of growth of the colony was obviously quite dependent on the capability of production of oxygen on the lunar surface. However, there is a lot of work left in future to be done. Judging the lunar colony to be a feasible project based on the subsystems and concepts selected for the various processes. There are numerous examples in the subsystem selection process where a different and perhaps better subsystem could have been chosen if advanced technology had been available to make certain of the subsystem functions more efficient or even possible. Therefore, recognizing that the significant research and development must be pursued before the lunar colony is a reality. You can go through the references for further deep study of the topic.